Welcome to Lecture 11, 1.5, Applications of Quadratic Equations. Okay, so remember, all word problems need to have, and see if you can fill this out without me having to tell you. What do all word problems need? Well, they need a let statement. That's where you define your variable and let me know what you're using. Hence the word let. And an equation. We're in math with algebra, so you need to have an equation using the variable you've just told me. Problem solving, and a complete sentence stating your final answer. Alright, so those are the four main things that you need to show for a word problem, and I will be looking for those and grading for those, so bear that in mind. Alright, so let's solve applications involving quadratic equations and geometry. So if it's a geometric problem, either the diagram will be given to you, or you can draw your own, and if you draw your own and label it, then you don't actually need to give me a let statement. Alright, so example 1. A trough at the end of a gutter spout is meant to direct water away from the house. The homeowner makes a drop. That should be a trough. I'll try to change that on yours. From a rectangular piece of aluminum that is 20 inches long and 12 inches wide. He makes a fold along the two long sides a distance of x inches from the edge. If he wants that trough to hold 360 inches cubed of water, how far from the edge should he make the fold? Okay, let's get a visual. But first off, in general, if you ever see someone's house, right, and they have the little rain gutters along the edge, there's always that one spout that comes down, and at the very bottom, sometimes they'll have like a little concrete block or a little trough so that when the water flows, so the water's raining, right, it flows through the trough, hopefully, and then it comes down the spout, and it's supposed to pour out over here, and oftentimes it runs down to the street. So what we're looking at is that little trough here. Okay, so that's just a visual. You don't need to draw that one. But what we're looking at is he has a rectangular piece of aluminum. Alright, and what do we know with that piece? It's 20 inches long and 12 inches wide. So 12 and 20, and I'm going to put inches to remember the unit. And then what do we know? He wants to make a fold along the two long sides. Okay, so he wants to make a fold. This way that he can fold it up looking something like this. And when the water comes down, it'll just pour right through. Okay, so that's what he wants to do. He wants to make something so that he can take the original sides, when it was a flat piece, and then he would fold them up to create sort of that, looks like a staple, maybe you could say a long staple, I don't know. So that's what his goal is. But he doesn't know how far in he should make the line. He doesn't know, so we call this x, because he doesn't know. He's going to take off x from both sides. So how far should he make the fold? Well, okay, so we have this information. We know that these sides are 20 and 12. I'm trying to make an equation. A lot of times with geometric problems, think of the different geometric formulas you have in mind. Right, so from formulas for rectangles. We have perimeter, which is 2L plus 2W. We have area, which is length times width. And we have volume, which is length times width times height. Well, what other piece of information are we given? I need to figure out which one of these formulas I want to use as the base for my equation. Well, notice I'm giving 360 inches cubed. And that little cube there tells me that I am looking at a volume formula, which means I want to use this formula to create my equation. Okay, so that's normally what you do with geometric problems. You think of the perimeter, area, and volume formula, and then you look at what you're given. So since we were given something in terms of volume, we're going to use the volume formula. Don't make life harder on yourself. Alright, so we're going to use the volume formula. So volume is length times width times height. But currently, my shape is not volume. So once again, I'm going to draw that trough shape that we had before. and label it. And from there, we can figure out what our length, width, and height are going to be. Alright, so taking a look at this diagram and transferring it to a 3D image so that I can use this equation. That's why we're doing it. Let's see, well, the bottom is going to be 12, but I folded up some of the edges. So that 12 inches, it loses x from both sides. So 12, it used to be 12, but I took away an x from both sides when I folded it up to create those sides. Well, I can simplify 12 minus x into just 12 minus 2x. Alright, so we know that that's one side. Now we need to figure out the height. Well, the height, that's just going to be x, because remember, we don't actually know how much we took away when we folded up the length, but we do know it's called, x, right? So each of these heights are x. And lastly, so I have the width, I have the height, I need the length. Well, the length was 20. So the question is, does that change? Well, I'm not taking anything away from the length, so no, it doesn't change. So there we go, we have 20. Alright, so my volume is going to equal my length, which was 20, times my width, which is 12 minus 2x, times my height, which was x. Let's go ahead and plug those in. So I have 20 times my width, 12 minus 2x times my height, which is x. And we're almost done. This is almost an equation, but remember, what did our volume equal? Our volume equaled 360. So we're going to go ahead and replace that volume with 360. And there we go. We have created our equation for solving. Yay! Okay, so we've created the equation, but now we need to actually answer our question, which is to figure out what x is. So let's go ahead and solve this. We can simplify both sides. Let's see. I'll distribute in that x. And I'll get 20 times 12x minus 2x squared. I could distribute the 20 in, but you know what? I think I can divide both sides by 20. And when I do that, I can simplify my problem instead of making it bigger. So the zeros cancel there, and then 2 can go into 36 18 times. So we have 18 equals 12x minus 2x squared. All right, now looking at this, notice each of the terms is even, which means I can simplify even further by dividing by 2. As usual, simplify if you can. All right, so what kind of an equation are we looking at? We're looking at a quadratic. How do I know that? I got the x squared. So plans for quadratic. Let's see. First off, I'm going to try to get everything equal to 0 to see if I can factor it. Why am I not going to try the square root property? Because I see that x to the 1 power, so square root property wouldn't really work here. So let's set everything to 0 and see if I can factor. I'm going to bring the 9. Actually, you know what? Because the x squared is negative here, I'll add it to the other side. So, and then I'll subtract the 6x from both sides. Alright, now I have x squared minus 6x plus 9 equals 0. And the question is, can I factor this? I believe I can. X minus 3 times x minus 3 equals 0. Yep. Okay, so for the zero factor property, we set each one to 0, and you need to show this step when you set each one to 0. Please make sure to show this step. Okay, important. I will be looking for it. All right, solving for both sides. We'll actually end up with the exact same answer. So x is 3. What was x? X was the amount that he's creating for the line. That's how far in he's going to go to create his fold. So, how far from the edge should he make the fold? Our answer is he should make the fold 3 what's? 3 inches. Gotta remember your unit. 3 inches from the edge. 3 inches in from the edge. Period. And there we go. That's an ugly rectangle. All right. Okay, our next one. So this time we're actually given a geometric figure, so we don't actually have to draw that. So we can kind of just skip the first step of making a let statement, since they already show us where our variables are. So we have a sail on a boat is the shape of 2 adjacent right triangles. Okay, really important when they tell us what kind of triangle. The hypotenuse of the lower triangle is 10 feet. One leg is 2 feet shorter than the other leg, so 2 feet shorter than the other leg. Find the lengths of the legs of the lower triangle. So they want us to find the lengths of the lower leg. Well, how could we do this? Well, a formula that always comes to mind when I think of a right triangle is the Pythagorean Theorem. Hopefully that rang a bell. If not, that's all right. So the Pythagorean Theorem states that if we have a right triangle, what we know is that the lengths of the 2 sides squared added together should equal the hypotenuse squared. All right, and we can use this formula. Why? Because we have a right triangle. If it wasn't a right triangle, we could not use that formula. All right, so as usual with geometric problems, always just think of a formula you knew from geometry class and see if you can use it in your equation. So the question is, we can use this if we know the 2 lengths of our triangle and the hypotenuse. Do we know that? Well, we know the hypotenuse, and we don't actually know the legs, but we know the algebraic representation of the legs. So we can go ahead and solve. Now it doesn't matter which leg you say is which, because you're doing addition, so it doesn't matter. I'll just go ahead and assign them like this. And then our hypotenuse is 10. So they kind of just threw the 4 in to throw you off. We don't actually end up using it for our problem. Let's see, so a squared, so that's going to be x squared, plus b squared, the binomial, equals c squared, which is 10 squared. Okay, if you want to pause the video and try to solve this by yourself, go ahead. All right, so we have x squared plus, okay, careful here. Question, can we distribute the 2 in? The answer is no. Please don't try that. That is very incorrect and will cost you some points. This is saying x minus 2 times x minus 2, which is very different, so please keep that in mind. All right, let's go ahead and FOIL these guys out. That's x squared plus x squared minus 4x plus 4x plus 4, equals 100. Then we can drop the parentheses while solving. Let's see, what kind of an equation is this? It's quadratic. Okay, so I'm going to try and do the zero factor property, so get everything to one side. So 2x squared minus 4x plus 4 equals 100. Let's go ahead and get everything to one side, so minus the 100 from both sides. And then we have 2x squared minus 4x, it's 96 equals 0. Before I try to factor, let's simplify. These are all even, which means I can divide them all by 2. Okay, dividing them all by 2, I have x squared minus 2x, and then 48 equals 0. Okay, so now let's go ahead and see if I can factor. 48. What are factors of 48? We have 1 and 48, 2 and 12. Let's see, 3 can go into 48. No, it can't. 48 divided by 4. 12. Oh, that shouldn't be 4 and 12. That's 4. That's 24. 4 and 12, okay, let's see. And then how about 6 and 48? Yeah, 6 and 8. Ah! I'm going to pause here. Why? I'm looking for, and remember the question here when factoring is what can you subtract to get a negative 2? I'm looking for something that has a difference of 2. These two are 2 apart. I'm going to use those. So we get x minus 8, x plus 6 equals 0. Solving each one to 0. Remember, this step is important. I get x equals 8 and x equals negative 6. I'm going to pause here. We have 2 answers. Are both of them usable? I don't know. Let's check. Does this make sense of my problem? I'm looking at the length of a triangle. It tells me that the length is 8. Well, that makes sense. And then the other one would just be 8 minus 2. So that's 6. Okay, that works. He's okay. How about negative 6? Can you have a length of negative 6? That's not possible. This guy would be extraneous. Alright, so thing to note here. If you cross out an answer, you need to write extraneous. And you need to write your reason. Lengths can't be negative. Okay, you need to let me know why you just canceled out an answer. Alright, so what was the question? The question was, find the lengths of the legs on the lower triangle. Alright, so the lengths are well, we know one was just x, so that would be 8. So 8, what was the unit? Feet. 8 feet, and now the other one is 8 minus 2, which is going to be 6. And 6 feet, period. And box your final answer. Alright, so one thing to note here before I keep going on. If you have scratch work, and you don't want to erase it, but you don't want me to grade it, what you can do is just box it off on the side of your paper and just write scratch work. Or you could write out the word scratch work. Okay, but it's important to let me know that you don't want me to grade it. So some of you on the quiz, I believe, you included your scratch work in the problem solving, and when it's included inside, I will grade it. So if you don't want me to grade it, box it off, put it on the side, and I will not grade it. As long as you write the fact that it's the scratch work. Alright, now let's take a look at the next problem. So, this is another kind of a problem. It's has to do with gravity type problems. So suppose that an object has an initial vertical position of s sub 0, that's how we say it, when there's that little guy down there, and an initial velocity v sub 0, straight upward. The vertical position s of the object is given by this equation. S equals half gt squared plus v sub 0 plus s sub 0, where the following. So I'm going to identify what each of these variables represent. G is the acceleration due to gravity. So on Earth, what is the acceleration due to gravity? G is either equal to 32 feet per second squared, or G is equal to 9.8 meters per second squared. You do not need to memorize this for this class. If this problem is ever given to you, you will be given this equation and you'll be given this piece of information. Okay? So in this class, you do not need to memorize these specific problems or these specific things in this box. Okay, so t is the time of travel. V sub 0, initial velocity. What does that mean, initial velocity? That means the velocity the moment you set it off. For example, if you think of having like a slingshot and you shoot the rock through the rubber band, the moment you shoot it, that would be considered the initial velocity. How fast is it going at? Boom, right there in the moment. And then S sub 0 is the initial vertical position. For example, if a person was, let's say, Waimea, yeah? So you get the rock and the water. If the person's standing up here at the very top, his initial position from the water, however, I don't know how high that is, 30 feet? Depends on where you are on the rock, I guess. So his initial vertical position would be 30. And then S. What does S stand for? The vertical position of the object at time t. So let's go ahead and go back to that Waimea Bay rock example. Alright, so you have the rock, you have the water, and you got the person. Let's say in the beginning, initial velocity was, or his initial vertical position, which would be S sub 0, that was 30, right? But when he jumps off the rock, his position in the air changes, right? When you're falling, or she, depends who's jumping, you're no longer at 30 feet, right? That was above you. But time has also passed. So let's say, possibly, this is an example, at 10 feet above the water, how much time has passed? Maybe 2 seconds. Probably only 0.5 or something. So that would be S. S is the vertical position at time t. So S would equal 10 feet, and time t possibly is 2 seconds. Whereas S sub 0 is still considered 30 feet, because that's the height you started at. So that's the difference between S and S sub 0. Alright. Let's take a look at the next problem. Okay. So, a toy rocket is shot straight upward from a launch pad of 1 meter above ground level, with an initial velocity of 24 meters per second. Write a model to express the height of the rocket S in meters above ground level. Okay, so they're asking us to write a model. So this whole problem is talking about initial velocity and all sorts of things like that. So I'm going to use the equation that's been given, which is S equals -1/2 gt squared plus v sub 0 t plus t sub 0. Now I need to fill this out. What am I given? I'm given initial velocity of 24 meters per second. Alright, so initial velocity is v sub 0. So v sub 0 is 24. And what else am I given? I'm given that the toy rocket is shot straight upward from a launch pad that is 1 millimeter above ground level. So the launch pad, sorry, not 1 millimeter, is 1 meter. So that would be the initial vertical position, S sub 0. Alright, S sub 0 is 1. And one thing we always know is that G is going to be either 32 feet per second or 9.8 meters per second. The question is, which one do I use for this problem? Well, notice we're given meters. So because we're given meters, we're going to go ahead with this version. So that is 9.8. Let's go ahead and fill those out. So I have G was 9.8, V sub 0 is 24, and S sub 0 is 1. Plugging those in, I get my model. Lastly, I'm going to go ahead and simplify this front part right here. That'll be negative 4.9 t squared plus 24t plus 1. Alright, now let's take a look at the problem we're given. It wants us to find the time s at which the rocket is at a height of 20 meters, round to 1 decimal place. So, we want to find the time, so find t when the rocket is at a height of 20 meters. So, when s, the height, is 20 meters. So, I want to find t, so these guys right here, when s is 20. All right, let's go ahead and plug those in and solve. So when s is 20, we'll get 20 equals negative 4.9 t squared plus 24t plus 1. Now we're solving for t, which means we are solving for a quadratic equation. I can't use the square root property because of the t to the 1 power, so I'm going to try and use zero factor property. If I can't factor this, we're going to do the quadratic. So subtracting 20 from both sides, we get 0 equals negative 4.9 t squared plus 24t minus 19. I don't think I can factor that. I don't know how to factor with a decimal, so we're going to use the quadratic. Before I do that, though, let's multiply everything by negative 1 to get our t squared positive. So by negative 1, by negative 1, and we have 4.9 t squared minus 24t plus 19. Now let's go ahead and set up the quadratic formula. What are my a, b, and c values? So my a, my b, and my c. Pause the video, try plug those into the quadratic formula yourself and see what you get. Okay, so plugging them in, I get t equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Alright, let me just go ahead and color code this so you see where each of the values went. Remember, you need to remember the plus and minus signs. Those play an important part in this formula. Okay, let's simplify. T equals 24 plus or minus square root of, simplifying the inside, we get 203.6 divided by, and on the bottom we get 9.8. All right, well, we have either the positive or the negative version to work with. So let's split our equation. Actually, let me go ahead and erase a little bit of this to give myself some room. All right, so we split. T is either equal to the positive version, so 24 plus the square root of 203.6 divided by 9.8, or it's the negative version. T is 24 minus square root of 203.6 divided by 9.8. Alright, if you plug those into your calculator and round out to 1 decimal place, you'll get that t is approximately 3.9 and t is approximately 1.0. Once again, we have 2 answers, but we have to check, do they both make sense for our problem? Well, let's see. Okay, so you have a rocket on a platform, right? Little rocket thing. You shoot it into the air, but what happens whenever you shoot something in the air? What comes up must come down, right? Boop. So this is asking what time the rocket is at a height of 20 meters. Well, we know the rocket starts at 1 meter, and at some point it hits the height of 20 meters. So what happens is on the way up, it crosses 20 meters at some time, and then on the way back down, it also crosses the 20-meter height mark. It crosses it twice, on the way up, then on the way down. So which one's which? Well, on the way up would be the shorter time, so at 1 second, it hits 20 meters, and then on the way down, so 3.9 seconds, it also hits the 20 meters. Okay, so that was just the visual, so both of these answers actually work for our problem. So let's go ahead and write in our answer. what do we know? The rocket is at a height of 20 meters at times 1. Now what are we talking about? Seconds? Yes, seconds. I know that because our formula was in terms of seconds. And this is also seconds. At times 1 second and 3.9 seconds. Period. Okay, work is nice and clean. I can see all the work. Also, if I can't follow the work when you're grading, then I'm not certain what's happening, so I can't give any points for what I'm not understanding. So always make sure that you can let your teacher, whoever's grading, understand the work that you're trying to show. Okay, last part. Find the time at which the rocket is at a height of 40 meters. Okay, so very similar to before. We're trying to find t when s is 40. So let's plug it into the equation again. So 40 equals, what was our equation? Negative 4.9 t squared plus 24t plus 1. Alright, so solving for t, let's go ahead and subtract 40 from both sides. So 0 equals negative 4.9 t squared plus 24t minus 39. When we put this in the quadratic formula, because I'm not going to try and factor a decimal, minus or multiply both sides by negative 1. Once again, why did I not try to factor? I don't want to try factor a decimal. So, in a sense, I chickened out. Alright, 0.9 t squared minus 24t plus 39. Now let's plug this into our quadratic. First I have to identify my a, b, and c values. Remember to include the negatives. A, B, C. Then t equals opposite of b plus or minus the square root of b squared minus 4 a c divided by 2a. Okay, simplifying. Let's simplify the first part, then the discriminant, which is this thing right here underneath the radical. It's called the discriminant. When I simplify that, I get negative 188.4 divided by 9.8. Let me actually clean this work here. That radical's too long. Oh, interesting. We have a problem. We have a negative under a radical. What's wrong with that? Well, remember, when you have a negative under a radical, that's when we start having imaginary numbers. That means we're not going to have a real solution. But we're talking about a problem with real solutions. So we don't actually have a problem or an answer in the real number line. So what would we say? Solutions are not real numbers. You could say imaginary. Alright, so what does this mean for us? Well, this means that there is no number t for which the height of the rocket will be 40 meters. Let's write this down. There is no number t. Remember, we were solving for t, for which the height is 40 meters. If I was thinking about this in terms of the problem, when we have our little stand and our rocket, this is saying that when I shoot the rocket in the air, it never actually reaches a height of 40 meters. We know at some point it hit 20 meters because of the problem above, but it seems that our rocket doesn't actually ever hit a height of 40 meters because there is no solution. It doesn't happen. Okay. So that's actually good to know. Instead of spending a ton of money trying to send a rocket up into the air, you could just work out a math problem and say, oh, our rocket's not going to make it. We got to figure something out. All right, so that's our answer. There is no number for which the height is 40 meters. Okay, email me if you need any help with the homework.